Otherwise, it can just be me and Shriram looking at each other. And Tia too. Hey Tia, well, have we tweeted from the Tetrate account that things are back up and running?
We can get that sorted. And we've already got questions.
Excellent.
Thank you, Ryan, for getting the party started.
Oh, yeah, sure.
Do you, Shriram, I mean, no reason for us to wait. We can go ahead and start tackling through. Do you want to start taking?
Yeah. So I guess the new way of doing things.
Oh, I'm sorry. Actually, let me record real quick. Oh, we already recorded.
Oh, no, yeah.
Tia, thank you. Sorry, go ahead.
We can. We are trying to avoid doing all reading certs from disk, and what we're trying to do is we're using the third-party JOTs that is issued by Kubernetes, and we're using that to actually authorize the pod and send a CSR to Istio, which in turn signs it after validating the pod's identity and so on and so forth. So, but that said, there is still support available for reading certs from disk, and some arcane environment variables that you would need to use in order to make that thing work. Actually, the old model is effectively deprecated, but if you're looking at how to do this for bare metal machines and VMs, then that model, even there, we're trying to make that model streamlined with what we're doing for Kubernetes pods. Does that answer your question, Ryan?
And so why don't you talk about the flow very briefly? So Citadel these days actually will go to the Kube API server for certs, right? For some types of certs. So why don't you, can you speak to that a little bit as well?
So yes, so I mean the way the flow works is that when a pod starts, the trustworthy third-party dot that is pushed into the pod by Kubernetes will be presented by the pod will create a CSR, present that jot to Istio along with the CSR, and Citadel will basically go and validate that jot with Kubernetes to make sure it is what it is, and then it will sign the CSR and then send it back. And this jot will just keep expiring every 12 hours or much less than that, and the CSRs will keep getting refreshed periodically along that way. And these CSRs are now loaded in the pod, and when Envoy starts up in the pod, it will load the CSRs directly from the pilot agent, the pod, and it will use that for doing all the mutual TLS stuff with other pods.
Yeah, and so one of the key advantages here is it gives us a stronger token to use to authenticate a pod when it comes into the system, right? So in previous iterations of Istio, we did not really have strong, we always used the service count jot as it was available. This is a better way to get that credential. And then one other thing to just touch on briefly, so about SDS specifically, about the secret discovery service. So for a long time in Istio, secret discovery service was not actually used. And even inside the context of the pod, secrets in Envoy were loaded from the file system. So today, one of the other changes is that we do actually use the SDS APIs to serve those secrets now. So they're not written into any temporary file system or anything. They're just passed over a domain socket using the UDS protocol. Okay, cool. So we don't use Kube API for certs, for issuing. We have custom PKI. How do we set up Citadel to be able to do this? That part I'm actually not too sure about with respect to how we're doing the service.
There are actually two or three extension mechanisms. One is in Istio we have this there's a protocol by which Istio can actually delegate that CSR signing to a third-party CA. But right now it's just implemented mostly for the Anthos service mesh, and it's called as Google CA. But once we make that protocol as something more standardized, then what that means is that you could just have that implement that API on your PKI authority, and this PKI system can actually validate the tokens and issue certificates directly. pretty much the same flow that would work for any other certificate provider that you want to use.
And then I'll ask questions here on behalf of them to follow on. So that's still going to use the SDS flow to get that actual certificate to an envoy, though, right? Yeah. So I want to call out that there's a little bit of a distinction here between purely using SDS to deliver secrets versus using the Kube API server to get those secrets. Those are not necessarily this one thing, right? So Citadel can use SDS to deliver secrets, however it is getting them. So does that hopefully help answer your question a little bit better, Ryan? And anybody else, just as we have people hop in, welcome. There, you should see a Q&A tab to the side. Please post your questions there. That is where we're going to answer questions. Please vote on questions that you see there as well, because we will use those votes to decide which ones we go in and answer. Make the protocol more standard. Does that mean it's not available in 151?
It is there. It's just not fully published as an API. It's there in the Istio repository, and you'll have to like dig around a little bit in order to enable that thing. So it's just not properly published, and with the same API guarantees and so on and so forth. That kind of stuff is not there.
What we mean by that is the protobuf APIs are there, but they are in the Istio repo, like by that code, if I'm not mistaken. Security still has it there, right, Shriram? Yeah. They are not in the Istio API repo. And so what that means is that they are not yet part of the formal Istio API contract, and there's not yet guaranteed stability there, right? So effectively, today, it is an API that is internal to Istio's own components or Istio's own implementation. The goal is that it be standardized so that there is better pluggability for Citadel. One other thing I'll mention is that there are already existing like Citadel Vault integrations as well, for example, depending on what exactly your requirements are. And then one other thing I'll just touch on real quick for 1.51 specifically, or 1.5 in general. We keep talking about like Citadel. So yes, Istio only has Istio D now as the one binary, but it's still meaningful for us to talk about the individual components, the logical pieces that make up that one binary, because those still exist, even in the new 1.5 world. So right, there is still logically a CA, and that is Citadel. There are still logically the traffic management pieces, which are pilot. They're just all in one binary now. So just one little note on that as kind of an aside.
So, and I want to add one more thing, Ryan, that if you have your own, like now I meant to mention the Kube API server thing, if you have your own PKI and you have your own mechanism for mounting certs inside the pods, then that should work today as well in 1.5.x or going forward ahead as well. Yeah, as long as only if you're starting to use Istio for fetching the certificates, then we use the pod jot and other stuff. But if you're mounting the certs on your own, like you shoot from your PKI, then you can still mount it on disk, and we can read it from disk and we'll serve it to Envoy over SDS.
You're talking to yourself, Zack. Can see your mouth moving.
Just saw I was muted. Yep, totally. I know. I was just saying. Any other questions? Please go ahead and keep dumping them in. Otherwise, we're gonna sit here and keep looking at each other. Comment. I'm a little bit redder today than normal. A little sunburned. Too long a bike ride. So that's always fun.
Here we go. We've got another question come in.
So it actually exists today, but it's actually highly discouraged, because if you're deploying a gateway in one namespace, you don't want the secrets for the certificates served by the gateway to be in a different namespace. That's, I mean, that would just mean that people can score on hosting secrets anywhere else and for any other host. And so from a security perspective, we strongly advise keeping the secrets in the same namespace as the thing. And yeah, so that would be the possession.
And maybe, and maybe one meta, like one step back from this specific question, just to expand a little bit on what Shriram said. One of the reasons that so in general, Kubernetes would like for you to keep secrets in the same namespace as the thing that is using the secrets. That's just a best practice. In general, when we're talking about the Istio gateways, You should probably not, unless you have specific requirements around like external load balancing into your cluster, you should not be too worried about running more pools of Envoy, right? So like, it is not unreasonable to run a pool of envoys per app that is ingressing, and they only have one secret that is the secret for that app. Not everybody's domain set up, like not the way that people host services is not always amenable to that. But if you can do that, that is a nice model that keeps things isolated and very easy to work with, and you're not going to have a range of outages where teams take out shared load balancers and that kind of thing. One of the knock-on effects tends to be that stuff like these secrets are easier and more consistent to manage as well. So that's maybe a little bit more general than the specific question, but that is one thing that's kind of worth thinking about. I know we had a question. Looks like somebody deleted it.
I think I answered it. It was a question about like, the certificates served by Citadel. Is it for the CA integration? Is it for north-south or east-west?
Yeah.
I answered that it was only for east-west traffic between the sidecars, not for north-south.
Yep, exactly. And in general, there is some machinery that exists in Istio today to handle some of those north-south, some of those external-facing certificates, but those do not go through Citadel, right? So there's like the cert manager. There's a cert manager integration, for example, that you can use to provision certificates that would be external-facing certificates that are not the kind that we use for East-West. So there are some integrations that you can use to provision certificates automatically for that external use case, but Citadel itself, by design, only mints certificates for East-West. Otherwise, keep questions coming, folks. Feel free to keep filing away. What do you mean by multiple custom ingress gateway configurations? Or Shriram, do you have more context on what the issue was?
What he means by multiple custom ingress. By the way, can he speak on audio? I mean, this is audio.
I think we actually probably could if he was. So
yeah, everyone has mic and webcam enabled, so you're more than welcome to join us in chat. If you and also make sure that you can hear us, like that would be.
How would I?
It's all enabled. It seems like it's all enabled.
Yeah.
Yep. So all you need to do is unmute yourself.
Oh, cool. So one of the things that we're doing, folks, for attendees here is we are also just brushing up on the webinar stuff ourselves. This is part of our ulterior motive for this entire thing is to learn to be able to use this. So welcome to the adventure with us. It's been a fun one so far. So I don't see how to let Ryan talk other than just making him a presenter.
Yeah, and look up some clarification from Ryan in terms of.
Yep.
So I'm just double checking that everybody should be able to chat out loud. Oh dear.
Any other questions, folks, in the Q&A? We're not. Upgrading cluster. Yeah. Okay. So upgrading Kubernetes cluster with Istio is always scary. General steps, procedures that we would recommend. So maybe it's worth talking about separately upgrading Istio itself from upgrading the Kubernetes cluster.
I think the question here is about the cluster itself and not Istio.
Yeah. In a lot of ways, I don't know. Like, well, Shriram, do you have something?
Sure, yeah,
otherwise, like.
So it depends on. An upgrading a Kubernetes cluster by itself is like it does impact all the components that are installed in the cluster, whether it's Istio or anything else for that matter. So there is not much from that point of view, unless if you have resources to spare, then you can always launch a mirror cluster of the newer version, and you can do the upgrades there and to make sure everything is working. and then you can change your DNS to point to the new cluster. Alternatively, you can actually have one single inbound cluster that is routing to the old and new Kubernetes clusters, for that matter. And as you're upgrading once you're happy with the fact that the new cluster has been fully functional, you can point the master load balancer to go to the newer cluster always. But then and so it depends on what technology you would use for the master load balancer as well. If you end up using Istio there, then once again you have a recursive problem of how do you upgrade that cluster as well. So it's that problem will always be there in that sense. If you're asking about upgrading Istio itself, there we have introduced a variety of mechanisms starting in 1.5 to actually ease the entire upgrade process. Specifically, you can now actually have multiple control planes running on the same cluster, where you can actually decide to gradually upgrade one or more namespaces step by step. You can just simply go and mark all the configurations in that namespace, Istio configurations, with in the control plane revision that you actually want to choose, and that's it. Then you just go deploy the new version of the Istio thing along with the old one, and only pods from that namespace will start talking to the newer control plane. And if all is good, then you can gradually roll that out to everything else and kill the old one. So we've done it in such a way that you can actually do this entire upgrade piecemeal.
And that was, to be clear, that was one of kind of the primary goals or advantages of the move to Istio D in 1.5, is that it specifically enables that. And yeah, so just one general, so as far as updating a cluster in place with Istio, I am not aware of any particular features of Istio that make that easier or harder than updating a Kubernetes cluster in place otherwise. And if there are some specific issues that you have hit, we would love to hear those. We would love to have issues filed or hear from you about what specifically those issues were, because that should not be that hard, or it should not be harder to upgrade a Kubernetes cluster in place than update it with Istio than updating a normal Kubernetes cluster. But to Shriram's point, updating a Kubernetes cluster in place in general is a rather hard activity to do. And I think it's pretty generally known across, it's much easier if you can do side-by-side clusters and if you can do total cluster rollover. That is not always feasible for people. That simplifies a lot of the problems that you might have. But yeah, specifically, if there are things that Istio makes harder to do that upgrade, would love to hear that, because that should not be the case.
Apparently, people have to be admins in order for them to be present, able to talk.
Yeah. So Teva asked, is the operator install default? Shriram, I actually don't know. My understanding was that both would work concurrently for the foreseeable future.
Yeah, it would, because they both using the same code. So it's you can either do it via Istio CTL or you can do it via the operator-based install. But we do suggest doing the operator-based install for a lot more flexibility in a production environment. And yeah.
But yeah, I mean. Sorry, I'm trying to mark. Other questions? Folks, keep them running.
Just want to say thank you all for your patience as we try and work through some of the technical issues, especially surrounding mics. Have enabled all of them and your webcams, and I'm trying to figure out why it's not working in the background. So please keep them coming in over chat, and we'll get this figured out hopefully before it ends, or before we do another one of these, certainly. So thank you.
So great question about extensibility in the world of mixerless. So that touches on a couple different things in Envoy, but maybe the biggest or most important one is WASM to talk about as extensibility. So generally speaking, what has happened, just so everybody has context with Mixer v2, it turns out that it's a bad idea in all of your proxies to have structured data, to destructure that data, send it to a point that has to restructure, right? So because of that, Mixer has been a long time bottleneck in the Istio kind of architecture, and so it's been desirable to remove. Mixer v2, or the kind of mixerless design, removes that. Most of the telemetry generation that was happening in Mixer is now happening in Envoy. It's not a complete replacement, but it does replace the vast majority of that functionality at the cost of extensibility, exactly to Ryan's question. Previously, Mixer had been kind of the extensibility point in Istio, and so that's now gone. The design, or the intended goal, is for WASM to be the replacement for that. So where you maybe would have written a Mixer plugin before, the expectation is that eventually those will compile into WASM against some framework. And I know that like Mandara over on the Google team had been working on that for a while. That is going to be the general path forward for further extensibility in Envoy in the future, is WASM. There is in place today, if you needed it like right now, and WASM doesn't cover some of the use cases you have, it is a little bare bones today. There is stuff like the Lua integration where you can drop in custom code to be able to do things like metrics and stuff like that today if you needed to. That is going to have slower runtime performance than doing it via WASM. Shriram, do you have more to add there around mixerless?
Nope, that's about right. Yeah.
So hopefully that answers the question. So unfortunately, and this is another case where like we joke about this continuously at Google. It was always a running joke that the old thing is deprecated and the new thing's not ready yet. That is exactly kind of the case of what happened here to some degree with the mixerless, right? So we figured it was more important. The performance aspects were important enough to warrant the move to a mixerless deployment, even though we did not have a full replacement yet, fully ready today for the extensibility features in Envoy, or for the extensibility features that Mixer provided in Istio. Those are not present yet in Envoy, but the goal is to add those back. And then there's another, so Ryan, if that didn't answer fully, please expand there. There's another question about Sidecar lifecycle. Yes, so Kubernetes 1.8 adds the notion of formal lifecycle as a type of resource that is attached to a pod. And in particular, the important thing that it gives us is ordering of startup. So historically, the problem with Istio is that multiple containers within a single pod in Kubernetes do not have any order. There's no ordering guarantee of startup. Effectively, they race at startup, right? And this has given people all kinds of issues. If my application is written to make a network call at startup to get configuration, and that fails, then my entire app fails, right? So this has been a long-standing pain point in Istio since the very first release, 2 years ago now, 2 years ago. Almost 3 years. So yes, we were very excited to see that finally Kubernetes is addressing this in a first-class way. The lifecycle, the pod, the sidecar element in Kubernetes should make life a lot easier. It should just eliminate classes of errors that people had before with applications that should just not be relevant anymore. Is the hope. And then I'm getting a note, it affects cron jobs too. In what way? Liam, I think you can speak. So, and just for audience folks, so there's a variety of y'all here. We also have a bunch of Tetrans in here as well, and I see in the list some other Istio folks, Liam and Lee, among others. So y'all feel free to chime in as well.
Due to the issues with mics currently, Liam is unable to speak.
Oh, fun. But yeah, so sidecars also help address cron jobs as well, right? Although I didn't offhand, I have not looked at how the two interact. I assume that you can just run a sidecar on cron jobs now that execute, and that now when the cron job ends, Kubernetes will actually terminate. The previous problem with jobs in Kubernetes before had been that the sidecar is not built to terminate; it's built to run for forever. And so we had a lifecycle problem where your job would run and then exit, and then the Envoy sidecar would continue to run. Therefore, your job would not get cleaned up, or it would appear to have never been terminated. Sidecars address that as well by turning down the sidecar when the job ends.
There was a question about what we add in Istio proxy. It's actually just like an envoy that's pinned to a particular version that we've tested against Istio, so that there's no surprises at the end of the day. Secondly, there's a bunch of filters, additional functionalities, extensions that we added on top of Envoy that that the Envoy community did not want to keep in their main repository because it was very Istio specific. So these things will have to live somewhere, and so these extensions are in the Istio proxy repository, such that when we ship, we actually enable these and then we ship them. That's basically, it's not a fork of Envoy. It's just it's just additional extensions and filters that we have added to Envoy.
Yep, exactly. And so one there, so specifically for a very long time, because of Mixer, we had special filters in Envoy to specifically interact with Istio Mixer. Those are now gone with Mixerless, with the Mixerless telemetry v2 system. So largely speaking, there are not very many remaining things that we do differently in the Envoy proxy that Istio uses, right? And in fact, it's one of the kind of overarching goals of the project to move to use upstream Envoy eventually. It's not super urgent for us, but we're slowly, originally the blocker was custom filters. We've largely addressed that now. And over time, we will eventually wind up using just the stock upstream Istio. But yeah, predominantly that exists as a way for Istio team to pin a particular Envoy version for testing. Question about Citadel and Sidecar injection. From an HA point of view, is it worth it to have multiple instances of Citadel? Does it make sense for the Sidecar injector? Citadel makes more sense than the Sidecar injector, for one. So these two are a little bit different. And then again, having Istio D changes this a little bit now as well, because you don't have the option anymore to just run one Citadel. If you need to scale out Istio D, you're going to have multiple Citadels running. Historically, this has mattered because at startup, Citadel would have to mint. Can you mute Shriram? Sorry, there's a background noise coming from you. So historically at startup, Citadel would have to go and mint a bunch of certificates for basically everybody, every identity that existed in the mesh. That obviously takes a long time because generating certificates is intentionally a time-bound process because we want it to be computationally expensive. That's a desirable feature for asymmetric PKI. Therefore, running multiple Citadels did help in a specific set of cases, like where Citadel crashes and where you have very many identities in your mesh and Citadel crashes and needs to come back, and it could take a long time. Having multiple instances is nice because those caches of certificates that they hold in memory are independent per instance. You're going to get that same effective behavior where Citadel is minting these certificates and holding them in memory to issue with Istio D as well. But you can no longer specifically scale out just Citadel to have multiple replicas. Instead, you're going to scale out all of Istio D. So to some degree, it's not a thing that you need to concern. Like worrying about Citadel versus Sidecar injection, cardinality is not something you need to worry about so much these days because there's just Istio D now. And so just have auto scaling set up for Istio D so that it can scale based on load, and trust Kubernetes spinning up new pods to handle some of the HA things would be probably my typical advice. Shriram, what do you different opinions there? Or, you're muted, by the way.
Sorry, I think that question is mostly moved since 1.5 because there's only one Istio D, and you can just scale it as much as you want. It handles all aspects of Istio. So, and you probably need to have at least 4 or 5 in a cluster, depending on the size of a cluster, and that's it. And you will not have to think about individual components and scaling them.
Liam, now you have the ability to speak. Have you got anything you want to add to any previous questions? Anything you want to cover?
Sure.
Did we cover the Sidecar point that you raised?
Yeah, so my point on the Sidecar was going to be currently there is no non-hacky way to do things like run a cron job with a Sidecar in it, right?
Okay, that is not.
Shut it down. but that gets solved with the thing.
Yes.
And the reason it hasn't really been fixed in Istio is because there is no non-hacky way to do it. There's comments in the issue about workarounds that AutoTrader use for shutting that down. But the real solution is like we need to have some kind of ordering in Kubernetes itself.
Yeah, maybe a short way to summarize that is like we really like Istio does not want to have to worry about job life cycles, because that's like we want the orchestrator to handle that, right? And so that's one of the reasons that we don't really want to address that in the first class way. So there's a question now. XCS v2 is frozen. Is Istio going to migrate to v3? Yes, when it's ready. Right. So one of the kind of interesting things to keep in mind here with all of the Envoy API design is that the group that drives most of that is out of Google. Harvey, in particular, is the primary lead for Envoy APIs, unless that has changed. Shriram can keep me honest. And he works in very close coordination with the Istio team, right? So I was when I was in Google on the pilot group, I had weekly meetings with Harvey where we discussed the incoming changes to the Envoy APIs to make sure that we were kept up to date with them, that they were moving in the right direction for us being Istio, that Istio was aware and could make changes to the Envoy needed. Right. So that is a regular flow of communication between the two organizations, between the set of Envoy contributors and maintainers and the Istio crew as well. So the answer is that yes, we will migrate to v3 once it's actually been implemented in Envoy and is ready to be used. Anything to add there, Shriram?
So yes, I mean, so the v3 is actually fully done in Envoy, and we are, I think by 1.6, we should have v3 support in Istio, and it's a very straightforward migration, and it's going to be there in by the May release of 1.6. XDS v3 support will be there. By Istio 1.6, we will have XDS v3 support.
Great. So this is an interesting question now around health checks. So health checks in general are kind of a pain in the butt to deal with. They've been a long-standing problem. Kubernetes health checks have been a long-standing problem, for example, because the kube API server didn't use certs that Envoy could listen to, for example. So this one, a little bit different. How do we handle that now? So certainly you could use a destination rule, but that would turn it off for an entire host. We really only want to disable it for the path.
So there was another question. I think is a question about Istio as HTTP load balance. So is the question about doing a health check on the Istio service, or is it on the Kubernetes health checks on the pods?
Yeah. So if it's a pod health check, one option that you have, if you can move your health check to a different port, that is one very easy thing that you can do. And then you can very easily disable mutual TLS on that entire port. But that's a little coarse-grained. I know that this has been a long-standing issue. Do we have better fine-grained answers for that, Shriram?
So we've actually fixed the health check problem for all the pods for a while. So we have the Sidecar injector will automatically rewire certain, we'll take your health checks and it will automatically convert them into pod local health checks, which will not be subject to all the MTLS constraints. And so I don't think that should be an issue. If you're looking at a health check for as a service as a whole, that an external service is calling into this Kubernetes service in order to check if the service is ready or not, then the destination tool would actually be the right way to do it, because you're just consuming that service from outside. But if you're looking at a health check for the ingress pod of whatever it is that you're talking about, then that should actually be handled automatically, because the Sidecar injector, there's actually an option that would automatically rewrite your existing pod health checks to use pod local health checks. The agent will actually do the health check for you, and then it will respond to Kubernetes in an appropriate way. So we rewrite all the health checks automatically for you.
And how do you turn that on? Or that should just be on automatically?
It should already be on actually, in the latest version.
Cool. Okay. Yep. Yeah, so make sure that you have 1.5 going, but hopefully that should address some of that. And if not, please chime back in and we can further answer. So there's one set of questions around XDS scaling down and XDS there. I'll touch on that one first before we go into XDS Kubernetes scheduling. So in general, gRPC streams are stateful. So gRPC has the notion of an unary RPC and a stream. The key difference between the two is that a stream is sticky to a particular server, a backend server. So when a client connects with a gRPC stream, every message on that stream will go to the same backend web server. If you're using unary gRPCs, gRPC will do load balancing across all the backends that it is aware of. So then the question is, what happens? So when Istio Envoy connects with a gRPC stream, that Istio instance is serving Envoy configuration. What happens when we scale down Istio? The answer there is that those envoys get disconnected. They are written to go and reconnect to their XDS server. We use the Kubernetes service name for Istio for that. They just go and reconnect after whatever their interval is to try. In the meantime, they will continue to serve with the last known configuration that they act. Right. So Envoy has configuration in hand in memory. It will continue to serve with the configuration in memory while it is attempting to reconnect to the XDS server. Once it reconnects, it gets passed a payload of configuration and it goes and applies that. Right. And if it goes and diffs the two config and there's no differences, it just carries on. So scale down is not like during a scale down of Istio, you're not going to see any like you may see like a couple of stale requests maybe go out of an Envoy as it's trying to shift over because endpoint updates didn't make its way yet. But that's going to be kind of an intermittent thing that we have like default retry policies to help mitigate against. But generally speaking, you shouldn't have to worry about downscaling too much. The only time it might become an issue is like stale endpoints or things like that. And even then, that's very transient.
So in terms of, I think Ryan asked a question about the debugging tools that we have in Istio for choosing why a particular route was chosen and so on. We are actually building a whole bunch of those tools. And in fact, if you look at all the XDS configs in Envoy, we actually annotated already with all the, the Istio configurations that were responsible for a particular route. But this is mostly a static analysis based system. And so if you look at the latest set of tools in the Istio analyze, and as well as the config propagation thing, it will actually tell you if a particular virtual service made it to one or more envoys, and it will also tell you like, hey, we found one or more inconsistencies across a few configurations, and we suggest you change it in an XYZ way. These are things that we cannot do inside the validation server because that only sees one resource. But the Istio, after you push the resource into Kubernetes, Istio will actually analyze all of them and spit out a bunch of analytics on the CRDs itself, such that when you go and look at the status of the CRD, it would tell you like, hey, this is probably going to cause a problem. And we pushed it anyway, but it will cause a problem, which then serves as a nice way to know what is happening.
And that code critically is identically the same code that runs when you do an Istio control analyze. When you use that command, that is the same code that is, you can do that offline pointed at a live cluster. That's identically the same checks that run on a continuous basis in Istio.
Right, but except for the fact that it also takes into account the set of services that already exist in the cluster, the runtime state of the system as well. So at runtime, it's a little bit more powerful, but it's statically offline also, you will still get a bunch of benefit. Yeah. But
and to be clear, you can run Istio control analyze against a live cluster offline. Like you can point at a running cluster to run.
Right, and so in terms of the debugging aspect as well, we do actually embed metadata about what virtual services were actually used for that route. So if you are using something like tracing, you should actually see enough tags on that route that say what configuration was actually the root cause for selecting this particular Envoy route itself. And at cluster level, we already have information about what destination rules were actually responsible for that cluster. So that should also be there. But then it's the question of when you do a config dump, you'll actually see the destination rules that were responsible for that cluster. But we can actually improve Istio CTL to actually even display what destination rules pertain to what clusters.
And there's like another aspect to this as well. So it has been kind of a long requested feature in the Envoy project to have like a route tester in some way, right? So like if I feed it in a fake request, it's going to tell me what backend it comes out. And so that may be kind of part of what you're getting at here too. So what Shriram described, right? So we annotate all the Envoy configuration with the source Istio config. So if you go and use like the Istio control proxy config commands to go pull down that Envoy config, you can look at that JSON data and see the Istio config that it came from. That's still not quite answering the question, why did this particular route get chosen for this request? So to answer, so that has been a long-standing question in Envoy. There has been some talk about that. Shriram, you could probably speak more to that. But as far as I'm aware, there has not been anything actually implemented for that. We've talked about, like, we batted around the idea of like taking the routing portion of Envoy's code base and wrapping it up in a CLI to be able to test with, for example. So that is something that is interesting and that people have thought about. It is not actually present yet. One other kind of piece of debug data that might be that is useful and worth calling out here as well for understanding why a particular route was picked or not is the response codes. What is the proxy response codes in the Envoy access logs? So if you look at Envoy's default access logs, there are 2 or 3 letter codes that Envoy will print when things go wrong or don't work correctly. There's like UC for unknown cluster, right? I don't know what service you're routing to. There's NR for no route. So that is another set of tooling or another set of data that you can use for exactly some of this route debugging. And that helps answer the question, where did this request go? It helps answer, it does not totally answer, but it helps answer what happened to this request inside of Envoy based on the configuration it has at runtime.
Yeah, and by the way, there is actually a route check tool in Envoy. I think it went in like a year and a half ago. And it would actually evaluate a runtime configuration, and it would tell you if a particular, like, what will be the route that will be chosen, and what was the reason, and so on and so forth. Which is, Envoy talks about a tool called router check. It would actually tell you, like, as to what routes were actually chosen. But it's part of the development flow. It is not part of a runtime tool in Envoy, but it's actually like, it's a built-in binary that you can actually build in from the Envoy source repository and run this test against.
Excellent. But yeah, well, like debugging is one of those continuous areas where we're trying to improve tooling, because we know it's pain. Like, we know Istio debugging is very painful today, even though it's gotten better, hopefully. But that is definitely a pain point that we're aware of. Cool. I think we have, so I know that we are a little bit short on time because we got started late. However, the Istio community call is kicking off like right now. So I do think we want to move over towards that. If we have any last second questions, please leave it. Otherwise, please email us. Tia, what is the best email for them to use?
It is learn@tetrate.io. I will pop that into chats.
Perfect. So if y'all have any other follow-up questions, that kind of thing, please drop those there, and we would love to take a look. Otherwise, thank you all for coming. I know this was a little rocky. This is our first time trying this too, but thanks for your patience. We appreciate it. Hopefully, y'all were able to learn some stuff, and we'll try to start doing this kind of thing a little bit more regularly as well. Otherwise, with that, everybody have a wonderful day.
Thank you, guys.